Here's another terrifying photo that we can use for educational purposes. This is a volcano plume. And again, we're trying to get all of that really crunchy looking spherical detail going on. And so we've already talked about the debris inside the plume, pushing things outward, adding temperature. That's good. But another main contributing factor to these shapes right here is the fact that it's hitting cold air. And that cold air is going to kind of dive inside of this plume and swirl around. And so we also want to have some vorticals outside of the plume. And the game plan is to have these particles outside and shooting velocity towards the plume like that. So how are we going to do that? Well, it's not too bad. We can actually take a time shift of the plume when it's one frame ahead. So take a time shift. That will basically means that we can scatter points on, let's say, a plume that's all the way out here. Once we have that, we can tell the points that are scattered out here to shoot velocity in the direction of where the current frame is. So the current frame is the borders that we see right here. And all we need to do is have some points along the current frame and along the next frame to, let's say, find the nearest point and shoot velocity in that direction. So that's the gist of how this works. And now another consideration is which field to generate this from. Because we could try to use density, but we're just going to basically be left with particles inside the cloud if we did that, and that's not ideal. We also have the option of temperature, but again, we're still inside of this plume, so that's not going to work. We could try using flame, same issue, it's not going to work. And basically that leaves us with the option of using a speed field. That's how intense the velocity vector is. So if this is a velocity vector, the speed is the length of that velocity vector. So we can isolate areas that are expanding outwards really quickly and use that. Or there's another option of using pressure. And I personally like the pressure if we can get that to work, because that is truly on the outside of these plumes. It also correlates with the areas that are moving quickly. And, well, when we look at the pressure field, it actually happens automatically on the outside anyways. So that kind of gives us nice little zones to work with when we're trying to source velocity and point it towards the cloud in the direction that it's coming from. So, with that being said, let's see if we can make this work with pressure. Before we dive into the DOPNet and start doing a bunch of nodes and all that, I want to show you visually what it looks like when we have pressure and how those values correlate to the outside of the plume. So I'm going to change our lighting here so that we end up with something like that. Notice that this is already pretty much on the outside, the perfect place to spawn those points. As I move things around, we can see that this really correlates with where those smooth clouds are happening. So I think that pressure is going to be a great place to scatter points, and then all we need to do is figure out how to get them pointing towards the surface of the plume itself. So that's why we're going to be using pressure. And as we add more substeps, this pressure will change dramatically. So let's just do a real quick test to see what it looks like when we have the full resolution. All right, and even with the resolution turned up, we end up with this. So that still is hitting the outside areas pretty well. This isn't perfect. Another way you could go about this is you could try to convert the VDB, this fog VDB, into an SDF, let's say, and then convert that into polygons. However, that is very computationally expensive. It'll slow down your simulation by a lot. So I think that the pressure field is going to be good enough to generally scatter some points and make this work. So we're going to run with that. for where to scatter these points. And if we need to add a bit more padding to our sparse solve, that could also be a good option if we want more of these areas showing up. But anyway, here nor there, this is a good start. As we work on these particles, it's good to turn off the existing interior particles so that we don't get confused. So be sure that that's all turned off. Let's go ahead and take our SOP solver, just make a copy of that, unbypass that, and set it to a different color. I'm thinking a very nice, little purpley, dark purple. Sounds good. We'll call this our exterior particles. Once we're inside of here, let's go step by step. We want to start by bringing in pressure. When we do our check for the scattering, let's also sample pressure right here with the volume slice. We can change this attribute if we want. That's probably, I don't know, easier just to keep it as is, but just for nice, clean workflow stuff. Change that, and change that, and change this, so that now we're looking at pressure. Okay, so we've changed pressure on all that. That's good. Scatter is fine for right now. We're not going to use the attribute randomize. Instead, I like using the point velocity because we have all these nice options for noise and stuff like that. So the initialization is going to be set to value. So we start with 0 for right now. We just want to test this to make it work first before we get too far on this. So we'll say conical noise, some random direction up to 180 degrees. The scale is 10. We just want to be able to see this at first. P-scale is good. We don't want to import from our interior particles. Instead, we want to do exterior particles. And the setup that we'll make is pretty much identical to the last one, except now we're having exterior particles instead of interior. This whole sphere and copy to points thing is something that I add just to see what the P-scale is doing, but it's not necessary for right now. So just turn that off. We have this aging, we have it blasting, and there's our output. So once we have that, we actually need to have a container called exterior particles. Fun fact, you only need one applied data, by the way. So there we go. Let's call this exterior particles. Plug that in. Give ourselves a mighty purple right there. That now is a container. We need to advect these particles, so we can just go to our geometry, spacebar, and paste in the exterior particles. That's all we need. Then, once we have that, we need to do something with these particles. So let's copy this gas particle to field. We'll call this our exterior particles gas to, well, we'll say point to field. Plug that in. We're not going to get access to our color picker, unfortunately, so we'll fix that later. But in here, we need to take a look at the exterior particles. And we need to take a look at an attribute called vel. This attribute is going to be the same thing as our destination field up here. I just have this doing a relative reference. Let's also scroll down. We'll set this calculation to add. Maximum will just take everything and turn it into the positive direction, so we don't want that. And that's all good from there. Also, we need to double check our SOP solver because we are not placing the outputs in the interior particles. We want the exterior particles. Also, if we go in here, this point velocity is giving us V, which doesn't line up with vel. So let's just create an attribute rename. So attribute rename and take V to vel. Easy as that. Okay, I think that's about it for getting this working. This is an important thing to mention, that you should really go step by step on every single node when you go to create this setup again, because as you just saw, there's a lot of things you have to do. So do be careful on that. Let's check it out by going to frame 30. All right, and sure enough, we do have velocity. we can see that we're making these little pockets outside of here. And again, that correlates with where our points exist. So that is awesome. In the next video, let's talk about how to get these points pointing towards the plume itself. And also, one last adjustment, let's add a bit of padding so that we're not cutting off some of these values with the active field. So go to advanced for the padding. I'm going to set that to about 0.7. This will add simulation time, but it'll also improve the quality. Let's check out how to take this further in the next video.